Hello, it's Miss Butler again. So you were supposed to read these pages before you started this video. If you haven't, pause and go do that. Section 4.4 and 4.5, we obviously learned about triangle congruence. We're going to build on that today, and we're going to take it one step further. So basically, whenever you have congruent triangles, you know that all of their corresponding parts are congruent. Okay, so if you can prove two triangles congruent, then you can go one step further and say that their corresponding parts are congruent. We use the acronym CPCTC to stand for corresponding parts of congruent triangles are congruent. So you can practice saying that really fast, CPCTC, CPCTC. Okay, so what we are going to do, if you read through the book examples, they had some really good examples and some examples of paragraph proofs, but we are going to add in a little flow plan because this visual sometimes helps you. Okay, so what you're going to do is you're always going to mark the picture with what you are given. So here I'm given C is the midpoint of BD. So if C is the midpoint of BD, then those are congruent. Also the midpoint of AE, and therefore these segments are congruent. And we are going to prove if angle A is congruent to angle E. In your book, what they'll say is angle A congruent to angle E? And then you're going to answer that with a little paragraph proof. Okay, in this picture, so right now we only have two sets of segments. We always need three parts to prove congruent triangles. So the other thing in this picture we can obviously mark here is that vertical angles are congruent. Okay, so in this picture, we have side, angle, side. Side, angle, side for both of these. Now, you always need three parts. If this helps as well, you could rewrite the actual congruencies. So AC would be congruent to EC. The angles would be angle ACB congruent to angle DCE. And it doesn't actually matter which direction you name the angle. So that is totally fine. And then BC is congruent to DC, those segments. All right, so these are my three pieces of information that basically flow into my triangle congruence statement. So I would say triangle ABC is proven to be congruent, ABC, so A, I have to start with E over here, and then go to D and then C. I want to make sure those are ordered correctly. And the reason those are congruent is by that side angle side we just said. Now, because I have congruent triangles, all of their parts are going to be congruent. So is angle A congruent to angle E? Well, here's A and here's E, which are in corresponding positions. So the answer is yes. Angle E is congruent to angle A, or angle A is congruent to angle E. And the reason you would give is CPCTC. So this is basically how you would plan what you are going to write. Okay, so take a second and pause and try to write out a paragraph proof like the book. Okay, welcome back. So what you are going to say is basically going through all the steps we just did. But you would say by definition of a midpoint, so you need to give a reason. So by the definition of a midpoint, then you can state that AC is congruent to EC and BC is congruent to DC. Okay, also by the vertical angles theorem, I always have to sound that out, theorem, you know that angle ACB is congruent to angle DCE. Therefore, triangle ABC is congruent to triangle EDC by side angle side. Then we know that angle E is congruent to angle A by CPCTC. So basically this is just explaining the plan that we made up here. It's called a flow plan. And that shows that angle A is in fact congruent to angle E. Okay, so next one. So I'm not going to go through all the gory details on the rest of these, but we're going to mark the picture. So GI, that should be a ray. I think it just freaked out on the software or something, but GI, so GI, you can even imagine the ray going through there, bisects the angle FGH. So FGH, so it's an angle bisector, meaning those two angles would have to be congruent. FG is congruent to GH, so FG is congruent to GH, so I'm going to mark those congruent. And then can we prove that FI is congruent to IH? So FI is congruent to IH. So I know that the last thing I need to figure out is this part, right? So that's the last thing. I know this middle part is definitely going to be triangles. So what I need to do is fill in why would those triangles be congruent if they are at all, because it's a possibility that they're not actually congruent. Okay, so in this particular picture, there are a couple of different ways you could go, but I'm going to go one way that we haven't talked about very much. So in this particular picture, you have this GI segment that is shared by these two triangles. So you can actually just mark that congruent basically to itself. So that GI is congruent to GI works for both triangles. So when you do that, then you get side angle side. So these triangles are going to be congruent. The reason for this second side, what you can say is that it's just a shared side. Officially, it's called the reflexive property of congruence, but for our purposes, we're just going to call it a shared side. So GI is congruent to GI because that's a shared side of both triangles. Okay, so you're going to go through, you're going to fill out these three guys. You're then going to fill out what the triangles are, and then you have your last statement because the triangles are congruent by side angle side. So take a minute and fill that out for yourself. Okay, so welcome back. So you're going to say here, first of all, the easy part is you can just say FG is congruent to GH because it's given. And that's all you have to write for that. Okay, and then the next thing, angle 1 is congruent to angle 2. And this is just a different way to phrase things, so you can write it however you'd like. But angle 1 is congruent to angle 2 because of the definition of an angle bisector. Definition, sorry, of an angle bisector. Okay, and then as I said, you can just say segment GI is congruent to segment GI because it is a shared side. Okay, therefore, triangle, and you can name this however you'd like to. I'll go with FGI, is congruent to triangle HGI by side angle side. And then just double check that FI. So FI goes with IH. Yep, those are in corresponding positions. So therefore FI is congruent to IH by CPCTC. There you go. Okay, next one. So here we're going to mark the picture. So AE is perpendicular to BD, and then AB is parallel to DE, and that's all we are given. So we could do a couple of Z's, get those congruent, get these congruent, but without a side, we have no idea if these triangles are congruent or not. So this is going to be, since it's angle, 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 that is not an appropriate congruency reason. So we're going to say that there's not enough information because the triangles could be congruent, but we don't know for sure. So this one, as soon as you know it's either angle, 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 or if you do angle, side, side, if that's a thing, then you're not enough information and then we can move on. Okay, so that one does not work. Okay, this one is interesting. So we're going to do the given. So angle A is congruent to angle E. BC, the segment BC is congruent to DC. So BC is this little guy and DC is that little guy. And then can we prove that AC is congruent to CE? So this one's actually really kind of difficult to see, but AC is this whole long segment here. So you don't want to use these small triangles in any way. Those aren't going to help you with AC. You actually want to use these overlapping triangles. So when you have overlapping triangles, I would recommend that you actually redraw them and relabel them. Okay, so this would still be C and that would still be C. This would be D and this would be B. And then this would be A and this would be E. So now we're going to remark everything. So BC is congruent to CD. Angle A is congruent to angle E. Now, this is an interesting picture because the third thing you can mark in this picture is that they share angle C. So I know that angle C is congruent to angle C. And again, that's because it's a shared angle. So this is a picture where you have a shared angle, whereas the 1, 2 above here is when you have a shared side. So here, yes, we can prove the triangle's congruent by angle, angle, side, right? Again, the side is not connected to both angles, so that is angle, angle, side. And then you would have your triangle congruent statement. And then you would have, yes, as long as double check that those segments are in corresponding positions. But yes, that would be true by CPCTC. So I'm going to let you guys fill this out. And if you have a question on wording, we can go over it in class. All right, we'll see you next time.